You're listening to the Modern Vital podcast, which explores the relationship between environmental factors and human health. Here is your host, Dr.Ben Reebs, founder of Portland Clinic of Natural Health and Modern Vital, elevating health and well-being one journey at a time. Stay tuned for fun, practical, and thought-provoking health tips, along with suggestions and insights into optimizing health and preventing chronic disease through integrative, naturopathic, and functional medicine approaches. Your body is unique, powerful, and intelligent. Your treatment should be too.
On today's episode of the Modern Vital podcast, we're going to talk about probiotics and the microbiome in the context of mold illness. And today's special guest is Kiran Krishnan. Kieran is a research microbiologist and a health and wellness expert who aims to make complex information understandable to all. He has founded a number of successful health and supplement companies over the last 15 years, including co-founding and leading Microbiome Labs, the preeminent microbiome therapeutics focused brand among healthcare professionals. And Kieran has conducted and published several research studies in scientific journals, has published chapters in scientific textbooks and reference books, has global patents, and is a sought-after speaker on human health and the microbiome. Welcome to the show, Kieran.
Thank you so much for having me. This is such an important and relevant topic, so I'm really excited to be here.
Well, it's a pleasure to have you here. And one of the first questions I like to ask my guests, is how did you get into the microbiome?
Yeah, a lot of it was I've been a science nerd from the very beginning. My parents are both in the world of science. My mom's a medical doctor. My dad's a microelectronics engineer, and I got a little bit of both of their brains. So my dad was very much into inventing things. He has over 200 US patents in his name in the world of microelectronics. My mom's a clinical clinician, being a medical doctor. So I got a little bit of both. And so I wanted to be in a world where I was inventing and innovating things that are relevant to clinical practice. The microbiome became a nice fit because I'm also very interested in kind of the unknown and these new frontiers of discovery, right? And arguably the microbiome is probably the biggest area of new frontiers and discoveries, that we've had over the last 10 years and will certainly have over the next 50 years, probably. So it all just kind of fit together, and it services the deepest interest that I have, both personally and professionally. So I jumped in with both feet.
Well, that's fascinating. Well, I've been following you for a number of years, and one of my specialties is mold illness. We have a lot of mold here in the Pacific Northwest. Anyway, I use some of your products, and I use spore-based probiotics. I use various probiotics for different types of mold. And I was doing some research. We about 1.5 million people die every year, according to relatively new data, of what's called deep fungal infection. And we know that there's over 100 trillion microbial cells in the gut. We know that about 70% of our immune system is in the gut, but we don't know a whole lot about how fungal overgrowth might interact with our microbiome and how probiotics might actually help cure or prevent. So I'd love to hear a little bit of your take on that.
Yeah, anytime we think about these factors like mold, whether we're talking viruses, mold, bacteria, one of the things to keep in mind is that the microbiome is an ecosystem, and it requires a certain degree of balance for the ecosystem to function properly, right? And I think most people wouldn't be surprised knowing that mold and fungus are a normal part of the biota, of the ecosystem of the body, right? It's perfectly normal that we have those types of organisms within our system. But of course, the moment we hit an imbalance scenario driven by a multitude of factors, anytime any of those organisms can overgrow, you can very easily get into trouble. This is true of bacteria, viruses, and of course, fungus and mold as well. The general thinking around fungus, for example, and the microbiota is that the microbiota, having a high diversity of microbes in the microbiota and having high levels of certain protective keystone species, they do a really good job of controlling fungal overgrowth in the body, right? And that ecosystem becomes balanced because the fungus also plays an important role, right? The fungus adds diversity to the microbiome. There are numerous fungi in the body that actually produce essential compounds. Some of them can increase the production of short chain fatty acids, for example, recycling nutrients from the body, breaking down nutrients that are coming in from food. So they have a useful role. But like any other part of the ecosystem, if there's an imbalance that's struck because of, say, antibiotic use or poor diet, lifestyle, additional stress, and so on, and they're all allowed to overgrow, what a lot of these organisms do when they're allowed to overgrow is they start expressing virulence factors, right? So many organisms that live in our system are opportunistic in their pathogenicity, meaning that they have the potential of being pathogenic, but they normally aren't when they're in the right balance, right? They understand that if they start to express their toxin genes and all that, they will quickly get fought off by the other microbes that don't want them to disrupt the ecosystem in that way, right? So there's a really interesting checks and balances. And I'll give a specific example of this, but the moment they're allowed to overgrow and they find themselves to be at a level that's abnormal, that's when they start talking to each other and going, hey guys, we have an opportunity here. We could take over. Let's start expressing our toxins and virulence factors to try to clear out space and fight for more real estate. And that's when you start to see things that are normally in the system overgrowing and causing infection, right? A great example of that is using Listeria. Listeria is a bacteria, but it's one of the most common foodborne illnesses, right? You can have two individuals that get the same exact exposure to Listeria through, let's say, contaminated food. The Listeria goes into the gut of both of those individuals. Now, one individual has a healthy, diverse microbiome. So the Listeria comes in at a certain concentration. And then that concentration cannot be exceeded because the rest of the microbes see it and start competing against it, right? Thereby keeping its levels at that basal state. And then eventually the Listeria dies off. That individual never experiences anything negative. The other individual, the Listeria comes in, that individual already has a disrupted microbiome. The Listeria sees that and starts to be able to multiply faster. They reach a certain threshold of their concentration, and all of those microbes signal to each other that, hey, we're at a good concentration. Let's start expressing our toxins. And then that individual feels the effects of that. They get sick. They get the GI symptomology, fevers, and all of that stuff. And they end up needing, antibiotics or whatever to bring it down, right? But the difference between those two individuals is, what does that terrain look like? Is their terrain allowing these opportunistic organisms to overgrow, right? And I'm sure you've seen in clinical practice that oftentimes when somebody has a candida overgrowth, for example, there are other things at work. They might have heavy metal toxicity, for example, right? That might go hand in hand. So their immune system, the biomes are disrupted because of heavy metal exposure. That's allowing the candida an opportunity to take over and grow at unhealthy levels. So it really, the mold and fungus issue, given that certain geographies have far more exposure to them than others, those geographies probably need even more focus on having a healthy, balanced microbiome, and that's part of where the probiotics come into play.
So can you explain a little bit about why a spore-based probiotic, like your mega spore biotic, why would, for example, I use little bits of it just as a powder in my really sick mold patients, and they'll have an intense die-off of candida or other things if they use too much. Now, of course, I'm not giving medical advice on this show, but can you explain why that is, how that works?
Yeah, actually, one of the key reasons is certain organisms that we get exposed to that are a normal part of our either commensal flora or normal part of our ecosystem that we're supposed to get exposed to. One of the things that they do really well is upregulating something called pattern recognition receptors in the immune system, right? So you've got all these sentinel immune cells that are roaming around your body, looking for things that shouldn't be there, looking for things that are too high in terms of their levels, to bind to them, to start neutralizing them, going after them and bringing their levels down. Mold toxin is one of those, mold itself, fungus itself, right? Now, often what happens is the immune system is looking for direction from the microbiome as to identifying what is present, what's there, and what shouldn't be there, right? So keep in mind, if we put ourselves in the perspective of an immune cell, for example, it really illuminates the problem that the immune cells have. There is roughly a 200,000 to 1 ratio of immune cells to microbes in the body, right? For every one immune cell that's like monitoring the system, it's got 200,000 microbial cells, which includes viruses, bacteria, mold, fungus, protozoa, and so on. And many of those are perfectly fine. They should be there, they're helpful, they're beneficial. So it's a real arduous task for the immune system to try to figure out which of those 200,000 is a problem and which ones aren't, right? And the immune system doesn't inherently have that information. And so the immune system counts on commensal beneficial microbes to tell it what is a problem and what is not. So the microbes that are beneficial, what they do is they upregulate the regulatory parts of the immune system, something called a Treg system, that will dampen unwanted attacks against good beneficial microbes. But then they can also upregulate something called pattern recognition receptors to help the immune system identify problematic organisms, right? So some of these microbes in our system that we get exposed to have that beautiful relationship. That's one of the reasons we love the spores, is because the spores have been shown over decades to upregulate those pattern recognition receptors, meaning they teach the immune system that, hey, here's something you need to pay attention to go after. So the die-off that some people experience if you go too high in the dose is that the spores go in, they identify the presence of the dysfunctional microbes, the fungus or the mold, for example. They do that by this process of quorum sensing, so they can read the chemical signature of different microbes, right? So they identify and they go, okay, here's a problematic fungus, and then they alert the immune system to come here and deal with the fungus. Now, the immune system that shows up is always the innate immune system, right? That's the fast actors. They come in there, they're non-specific, they just come to the region and they carpet bomb everything, right? They use complement systems and granulations and all, and they carpet bomb everything. So there's a lot of inflammation involved, right? So if you imagine that is happening at a larger scale throughout the body, that individual is going to feel a lot of die-off and a lot of Herxheimer type response. When you do it at a smaller level, that's happening at a lower level on an ongoing basis, so you control the response, right? So at the end of the day, what's happening is the spores are educating the immune system as to what and who they should be going after and where that problematic microorganism is. So they are upregulating pattern recognition receptors, and a specific version of pattern recognition receptors called toll-like receptors.
Oh, that's fascinating. Thanks for that. So, a little known fact people don't really talk about much is that fungus can actually invade our epithelial tissue and our endothelial tissue. And, you referenced these virulence factors. I know that some types of mold have like hydrochloric acid as a virulence factor, and they'll kind of break their way through the cells. And then they literally invade the blood through their hyphae, which are like those little budding ways of, giving birth to each other and multiplying. I guess the question for you is, how does that tie in with leaky gut? And is that in line with what you're talking about, where there's literally just a higher level of these critters running around? They're like, hey, we've got an opportunity. Let's go. Let's go through that epithelial cell, and then let's go into that endothelial cell. We're making our way to those blood vessels.
That's exactly right. Yeah. And, they've learned over time that if they want to spread through the body, the easiest way is through the blood system. Right. And most microbes know this too. Most pathogens know this. So if you think about C. diff, for example, one of the reasons why you get bloody diarrhea, C. diff infection, is because Clostridium is trying to eat away at the mucus layer and get to the blood. It needs iron as part of its propagation, but then at the same time, it's trying to get in the blood so it can spread throughout the body, right? So fungus and mold does the same thing. They want the blood. The iron in blood is really important for them, for their metabolic processes, but then they also want to spread through the body through that. And the little hyphae are really problematic because that's them basically sending their little progeny throughout the body so it can make its way all around. And that's exactly right. So they know that when the body is healthy, when there's a good microbial balance and the immune system's working correctly, what is happening is they are prevented from making those real egregious moves because they know that the microbes and the immune system will shut them down immediately. Not only will it shut down their potential invasion into the tissue, but it may also kill them, the colony that's trying to make it through, right? So they're smart enough to know, okay, let's lean back. We don't want to draw any attention to ourselves. Let's just do what we do at the level that we are. But the moment the opportunity arises, that's when they express all those factors of, like you said, breaking through the tissue, going through their life cycle faster. So they have these hyphae life cycles that they can then send off to the rest of the body. And one of the biggest signals for all of these opportunistic organisms is inflammation, right? They've all learned that when there's inflammation present, meaning elevated levels of certain cytokines like IL-6 and IL-1 beta, it's an indication that the host is undergoing a lot of stress and the immune system is distracted, right? Because if there's inflammation everywhere, it's basically like a bunch of fire signals everywhere, fire alarms, and the immune system is like a bunch of firemen on a fire truck. They have so many places to go. So the pathogens are like, okay, this is a great time. Everyone's distracted. It's chaos, right? Let's do our thing. So leaky gut provides that environment for many of these opportunistic pathogens because it creates systemic inflammation through the body. So as a clinician, you probably one of your tactics is let's deal with leaky gut in many of these people as well, right? Because we need to stop the systemic chaos that's happening, which is one of the key signals that allows these opportunistic organisms to go, this is our opportunity. Let's go in and get throughout the host as much as we can.
Kieran, you had mentioned, the iron is kind of a substrate for these infections. In almost all of my chronically sick mold patients, we see really low ferritin, and it's classic in Lyme as well. Is there a connection there?
That's absolutely right. Yeah. So there's a low ferritin because you've got microbes utilizing a lot of the free iron and so on, right? And so these people will immediately also be anemic in many ways because their own blood cells can't hold on to iron appropriately because you've got all of these microbes all over basically scavenging the iron. You've actually got microbes that can produce chelating agents in the micro environments and actually steal heavy metals, not heavy metals, but metals like iron and all, and calcium and magnesium and all that away from the host and hold on to it in their little micro environments, right? So absolutely, those individuals may also be very, deficient in things like magnesium or zinc and things like that some of these organisms can hold on to.
Wow. Well, I mean, it just makes sense. We know that antibiotics kind of wipe out the good flora, and then, candida and fungus will kind of come in. So it makes sense that by putting the probiotics back in different types and kind of get everything balanced again, the candida and the mold are maybe going to go dormant or die or at least get lower or be prevented from propagating.
Yeah, absolutely right. And I think one thing that's really important for people to understand is that literally every part of the inside and outside of our body is covered with microbes, right? With the exception of this thin mucin 2 layer in the GI tract, that's the only sterile area of the body. But outside of that, everything else is covered with microbes. And they're always going to be covered with microbes. There's never a moment where and a part of, like, for example, your upper layer of your mucin or your skin or any other part of your body is devoid of microbes for a period of time and then microbes show up. It's not. There's always a battle for that real estate, right? So something's always going to be living there. And the way to think about it is, what are the conditions you're putting in place to dictate who gets to live there? Right? If the system is corrupted, if there's lots of inflammation, if there's heavy metal exposure, if there's poor diet, so there's low nutrient absorption, if the immune system is deficient and doesn't have enough adequate nutrients to support its function, like short chain fatty acids and magnesium and zinc and all those basic things, vitamin D, right? Then all of those things create a void in which some of these pathogens have the opportunity to take over that real estate. Right. And then what we need to do is, it's a battle for real estate. We need to create a condition that allows the good commensals to compete with them and take over the space. So somebody's always going to be in the space. Who's in the space is determined by what condition we put our system in.
Well, and that just brings up that fascinating topic of the biofilm, and how the mycelium in the fungus can go right into that biofilm and then kind of evade the immune system and then communicate, like do, and I mean, and then basically hide. Have you found that probiotics can eventually kill that biofilm, or do you find that it just kind of stays there?
Yeah, it depends on the probiotic. So, and the biofilm part of it is really interesting because there's also evidence that some of this fungus can create collaborations with pathogenic bacteria and together make a robust biofilm and support one another. For example, Candida can do make biofilms with Streptococcus or Staphylococcus, right? So then they create these little pathogen condominiums where they keep building layers upon layers of the biofilm and they support one another within the biofilms because they both have the same egregious motivation. And so, in order to break down the biofilm and get to it, you need the right enzyme mix to be able to do that. And some microbes, and this is another reason we like the spores a lot, is the spores produce alpha amylase and other enzymes that can actually break down those pathogenic biofilms, exposing them to the immune system. Because it is really hard for the immune system to not only, of course, get to the organisms, but even detect that they're there. Right, because all the things that they've learned in terms of pattern recognition, they can't see those patterns because they're cloaked in the biofilm, right? So it's a really good mechanism for these pathogens to evade the immune system, but you need microbes that know this and can go and go, I know there's something wrong here. I'm going to chop this little cover up, and then that's going to release the pathogens, and then that's going to allow for the immune system to go in and get them.
Curious, like, how do you find that the probiotics help with the hydrochloric acid levels? Because, I treat that a lot, with digestive bitters and, good old-fashioned naturopathic medicine. And of course, we know that candida and fungus overgrow when the gut's more alkalotic. But what's the connection there with probiotics?
Yeah, that's a great question. So normally it's okay. So there's one connection that's really interesting, and that's the role of histamine, right? So histamine is one of the core signals for the production of hydrochloric acid. So you've got minerals, and then you've got histamine, which are both the ones that stimulate the cells that produce hydrochloric acid to produce it. Now, but that histamine has to be concentrated by the glands that produce hydrochloric acid. Now, if you've got a dysfunctional immune response and you've got overt expression of histamine in other areas of the body, that can actually corrupt the activation of hydrochloric acid via histamine in the stomach itself, right? So that's one mechanism in which where you're getting the signal in the wrong place because you've got histamine being expressed throughout the GI tract rather than in the area where the stomach acid is formed. Now, the other problem is we have a little bit of a feedback mechanism where if our gastric mucosa is compromised, right, that is a protector against damaging our own stomach from hydrochloric acid. And hence, if you get a lot of disruption to it through H. pylori, you end up with ulcers and so on. So we have a little bit of a feedback loop in our stomach, where if you've got a really thin gastric mucosa and lots of exposure of our own gastric membrane to hydrochloric acid, that can create a feedback loop to slow down hydrochloric acid production. But to rebuild the gastric mucosa, you need the activation by goblet cells, or the activation of goblet cells that produce the mucin. Goblet cells require butyrate in order to do that. Butyrate requires the right probiotic mix in the gut in order to become produced from fibers and things like that, right? So you've got this feedback inhibition going on with the gastric mucosa. Then you've got the role of histamine as a signaling molecule, but then histamine becomes corrupted by being expressed throughout the GI tract in a non-specific way because these people are highly inflammatory with the disrupted microbiome.
Wow. Well, thank you so much for joining us today, Kieran. Where can people find out, more about you? Where can they find you online?
Yeah, and it's my pleasure. Thank you so much for inviting me. If they reach out on Instagram, I try to post as much of what I do on there from lectures and interviews and just tidbits and information. That's at Kiran Biome, KIRANBIOME. There are a number of new projects that I'm working on as well, and I try to keep people up to date on there. So that's probably the easiest place to reach out. And I do try to engage with people as much as I can. If they have thoughts and ideas and questions, I'm happy to try to point them in a direction or two, or recommend practitioners and things like that. Don't do medical advice on there, which nobody should on social media, but happy to point people in a direction where they can do their research.
Oh, well, thanks so much.
Yeah, it's my pleasure. Thank you.
That concludes today's episode of the Modern Vital Podcast. We'd love to hear from you. We really value your feedback. And if you have any questions or suggestions, please reach out to me at ben@modernvital.com. Also, please leave us a review if you enjoyed this episode. And we look forward to having you join us next week for another exciting episode of the Modern Vital Podcast.